Top 10 ugly rocks that hide diamonds and other gems inside. They look worthless, cracked, dusty, and forgotten. Rocks that blend into the background are tossed aside without a thought. But beneath their rough, ordinary surfaces lie some of nature's most astonishing secrets. This video explores 10 of the ugliest rocks on the planet, each potentially hiding as rare and valuable as the most coveted gems in any museum collection. These aren't just rocks. They're geological decoys, misjudged and misunderstood. And once cracked open, they reveal that beauty isn't always easy to see. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th, Thunder Eggs, the volcanic ugly duckling. You've probably seen one without realizing it. A rough, potato-shaped lump lying forgotten in dry riverbeds or desert fields. Dull gray to muddy brown, pitted like dried cement. Thunder eggs are some of the most deceptive rocks on Earth. To the untrained eye, they resemble nothing more than broken volcanic waste. But inside, a thunder egg can hide one of nature's finest surprises: agate, quartz, chalcedony, or, in rare cases, even fire opal. These geological oddities form inside ancient rhyolitic lava flows. As lava cools, trapped gas bubbles create hollow spaces, and over thousands of years, mineral-rich groundwater seeps in, depositing layers of silica that crystallize into mesmerizing patterns. While some thunder eggs crack open to reveal nothing but plain stone, others conceal concentric bands of colored agate or flashes of opal so vivid they rival polished gemstones. One specimen found in Oregon, dismissed as junk, was split open to reveal bright red fire opal worth over $1,800. Proof that value doesn't always shimmer on the surface. Thunder eggs don't glitter, they don't shine, and they certainly don't announce their treasure. But that's the point. Their actual value is hidden beneath a crust of mediocrity, waiting for someone curious to break them open. Thunder eggs reminds us that the most astonishing beauty can lie buried in the most unremarkable stone in a world obsessed with appearances. Ranked 9th, Conglomerate Rocks, gravel that glitters. Among the most overlooked rocks in the natural world, conglomerate often goes unnoticed. With its rough, chaotic surface and mismatched fragments, it resembles nothing more than geological concrete. Pieces of gravel, sand, and mineral debris are haphazardly cemented together. Some smooth, others jagged, forming a rock that appears more like rubble than potential treasure. But beneath that disorder lies an unexpected beauty. Conglomerate rocks are time capsules of ancient river systems. Over millions of years, streams and floodplains carry gemstones and ordinary pebbles, tumbling until nature sealed them within a solid mass. Hidden inside the matrix, garnet, spinel, zircon, or even sapphire glints are concealed between ordinary quartz and feldspar. Unlike well-defined crystal pockets or structured geodes, conglomerate offers no clear sign of what lies within. The gems are unannounced, random, and often small, yet undeniably real. In some recorded finds, spinel crystals as large as half an inch have been embedded within the rock, weighing up to 2 carats and valued over $600, depending on clarity and color. Conglomerate does not gleam or catch the eye at first glance. Its value cannot be guessed from the surface, and perhaps that is its greatest strength. It represents the hidden complexity of Earth's slow, messy, yet deliberate artistry. Where others see rubble, geology reveals a mosaic. In a world obsessed with the polished and perfect, this stone reminds us that value is not always arranged nor announced. It is discovered. Ranked 8th, Limonite Pseudomorphs, iron coats hiding pyrite or garnet. Limonite pseudomorphs are relics of transformation, stones that wear one identity on the surface, yet preserve the memory of another beneath. At first glance, they appear as nothing more than rust-colored lumps, rough, pitted, and often mistaken for corroded scrap metal. But these iron-rich formations carry geological evidence of change, where one mineral has quietly replaced another, atom by atom, over time. The term pseudomorph itself means false form. In the case of limonite, it frequently forms by replacing pyrite, also known as fool's gold. Pyrite's crisp cubic structure often remains perfectly intact, even after being chemically overtaken by limonite. The result? A rock that appears to be a fragile chunk of oxidized iron still retains the sharp geometry of the pyrite that came before it. In some regions, especially across parts of the United States, Limonite pseudomorphs encase garnet, adularia, and other metamorphic minerals, trapping them beneath an outer coat that masks their brilliance. Because limonite is dull, brittle, and stains easily, collectors often pass it over. Yet those who analyze beyond the surface sometimes discover specimens with perfectly preserved crystal outlines and unexpected inclusions. These stones are, in effect, geological decoys, masking the value behind decay. What looks corroded or collapsed may be mineral memory frozen in time. They remind us that not all changes erase the past. Some cover it in iron. Ranked 7th, bauxite, the ugly ore that can birth sapphire. Bauxite is one of the world's most essential ores and one of its most misunderstood. It is a dull, clay-like rock, usually red to brown, often powdery to the touch, and commonly found in dusty pits or eroded hillsides. It lacks luster, symmetry, and visual appeal. Most would call it ugly, few would call it valuable. But hidden within this humble ore lies the potential to birth something extraordinary: sapphire. Bauxite is the primary source of aluminum, composed primarily of hydrated aluminum oxides. But these aluminum compounds can transform under intense pressure, heat, and the right geochemical conditions that existed millions of years ago. The result? The formation of corundum, the mineral family that includes ruby and sapphire. Across parts of Asia, Africa, and even the southeastern United States, bauxite deposits have been linked to the formation of gem-quality sapphire. In rare cases, fragments of sapphire crystals are found embedded directly within bauxite-rich zones, hints of a transformation that occurred deep beneath the surface and was long forgotten. These discoveries are infrequent but real. Some corundum crystals found in bauxitic soils have been valued in the thousands of dollars per carat, especially when they exhibit the coveted deep blue or padparadscha hues. On the surface, bauxite offers nothing that sparkles. No faceted edges, no crystalline faces. Yet beneath its dusty exterior lies the elemental foundation for one of Earth's most iconic gems. It's a reminder that the extraordinary doesn't always begin as such, and that even the most unimpressive rock can carry the potential for brilliance within it. Ranked 6th, serpentinite, the snake skin that hides jade. In ancient cultures from China to the Americas, specific stones were believed to be alive, guardians of the earth, whispering truths only time could hear. Serpentinite was one of them. Dull, waxy, and greenish-black, it earned its name from its resemblance to snakeskin. Mottled, scaly, almost reptilian. Most pass it by, dismissing it as just another low-grade, metamorphic rock. But serpentinite has secrets, and sometimes it hides jade. In deep-sea fault zones, serpentinite is born when ultramafic rocks from the Earth's mantle are pushed upward, altered by water and pressure into this strange serpentine texture. In rare cases, under immense heat and mineral-rich flow, this process creates veins of nephrite jade locked within the larger serpentinite host. The transition isn't apparent. There's no glitter, no flash. Only those trained to read the subtle color shifts in smooth grain will recognize its potential. Throughout history, serpentinite has been quarried, carved, and misunderstood. In Central America, it was shaped into ceremonial masks. In Asia, it was sometimes mistaken for low-grade jade. And sometimes it was jade, merely wearing the serpent's disguise. Even today, pieces found in California, British Columbia, and Taiwan have yielded nephrite that polishes to a smooth, rich green, valued at hundreds of dollars per pound. But its true worth lies beyond commerce. Serpentinite is a geological shapeshifter, a rock born from the ocean floor, carrying the story of Earth's shifting plates and hidden pressure. It doesn't reveal jade willingly. Like its namesake, it guards what's precious beneath the surface and is meant to deceive. Only the patient and the curious ever find what lies inside. Ranked 5th, Rhyolite, the lava scrap that grows opal. High in the deserts of Nevada and scattered across the ancient volcanic fields of Australia lie broken cliffs and windswept plateaus, barren, cracked, and sun-bleached. The rock here crumbles in the hand, soft and porous, the color of ash and rust. On the surface, it looks like nothing. But beneath this volcanic wasteland lies one of Earth's most surprising gem sources, rhyolite, and the hidden opal it sometimes protects. Rhyolite is a silica-rich volcanic rock formed from thick, slow-moving lava that cooled above ground. As it hardened, gas bubbles became trapped, leaving behind cavities, small voids that once held nothing but air. Over millennia, water rich in dissolved silica seeped into those spaces. The chemistry was subtle but relentless. Slowly, layer by layer, that silica began to harden, not into quartz, but into opal. In remote sites like Virgin Valley, explorers have uncovered rhyolite nodules where entire pockets of precious opals, rainbow-like and fire-lit, had grown inside old volcanic gas chambers. These opals can flash electric blue, green, orange, or even red. Some weigh several carats and command prices upwards of $2,000 per stone, depending on clarity and color play. But rhyolite doesn't give away its treasures easily. Most pieces break to reveal nothing. Others hold common opal, milky, without fire, and only a rare few contain the prized color play collectors dream of. To the untrained eye, rhyolite is throwaway rubble. To the persistent, it's a geological puzzle with unpredictable rewards. In landscapes shaped by fire and time, this lava forgot to sparkle until the right hand cracked it open. Ranked fourth, schist, the sparkling slab you'd mistake for junk. Resting quietly in countless rock collections and forgotten excavation sites, schist is one of geology's most misunderstood stones. Layered, flaky, and dark in tone, it often resembles little more than a slab of compressed sediment, an unremarkable relic in a world obsessed with brilliance. Yet when observed under the right light, schist reveals a secret language written in mica, garnet, and glimmering mineral veins, speaking volumes to those who know how to listen. Schist is a metamorphic rock born deep within the earth under immense pressure and moderate heat. Over time, its mineral grains align into parallel bands, creating a texture known as foliation. This banded structure allows certain minerals to grow freely within the matrix. In specific regions, especially across the Appalachian Mountains and parts of Scandinavia, schist has been found to host gem-quality garnet, kyanite, and even ruby, formed slowly within its layers like seeds protected by centuries of stone. Unlike gem-bearing rocks that dazzle at first glance, schist conceals its wealth within a camouflage of complexity. Mica flakes, biotite or muscovite, scatter the light with a silvery sheen, often mistaken for simple sparkle. But a closer look may reveal garnet crystals, sharp-edged and wine-colored, measuring up to half an inch wide and valued at several $100s per carat when properly cut and polished. In many ways, schist teaches patience. It doesn't reveal beauty easily, nor does it demand attention. It's a stone for those who observe slowly and appreciate that a record of transformation may lie beneath the mundane. Heat, pressure, time, and hidden light. Ranked third, Pegmatite, the chaos rock that breeds gems. If chaos had a form, it would be Pegmatite. This is no ordinary rock. It's a battlefield. Geological warfare frozen in time. Pegmatite forms in the final, volatile moments of magma cooling, when the Earth's molten heart squeezes out its last, concentrated breath of rare elements. The result? A stone riddled with disorder, giant crystal shards, jagged fractures, and strange inclusions packed together in ways that defy symmetry. And amid the chaos, gems. What makes Pegmatite so explosive for gem hunters is its chemistry. As magma solidifies, water and rare elements are pushed aside into shrinking pockets. These isolated zones become pressure cookers of crystal growth. In the right pegmatite, you'll find tourmaline in neon pinks and greens, aquamarine that forms in translucent blue rods over 6 inches long, and even topaz, spodumene, or beryl. Some pegmatite crystals grow to absurd sizes, measured not in millimeters but in feet. One pocket in Maine yielded an aquamarine crystal weighing over 60 pounds, while a Brazilian pegmatite produced a single tourmaline crystal valued at $1.2 million. But don't expect symmetry or predictability. Pegmatite is messy. One section may be lifeless feldspar, the next a riot of color. It's this unpredictability that makes it so alluring and so frustrating. To find treasure in pegmatite is to understand the beauty of disorder. It's the rock that proves nature doesn't always follow rules. Sometimes brilliance is born from the breakdown. Ranked second, Geode, plain, outside, crystalline universe, inside. Step into any natural history museum. One display always draws a quiet crowd, the Geode. At first glance, it looks like a common rock, rounded, dusty, cracked, with chalky brown or gray skin. Nothing about it suggests value. But when cut open, it reveals a world that defies expectations. Glittering amethyst, clear quartz, or smoky crystals lining the hollow of a natural cathedral. Geodes are the ultimate geological paradox. Formed inside gas bubbles of volcanic rock or dissolved cavities in the sediment, they begin life as voids, empty, fragile, and easily missed. Over thousands, sometimes millions of years, mineral-rich groundwater filters through these spaces. Drop by drop, crystals form on the inner walls. Silica, iron, manganese, and calcium shape complex interiors from simple beginnings. No two geodes are alike. Some sparkle with clear quartz points, others glow with deep purple amethyst or glisten with microcrystalline druzy. In regions like Brazil, Morocco, and the American Midwest, large geodes have been discovered housing crystals over 6 inches long, with market values exceeding $5,000 depending on clarity and size. Yet they remain deceptively plain on the outside. That's the power of the geode. It teaches patience, rewards curiosity, and reminds us that time and pressure, not polish, create beauty. So next time you hold a rough, unremarkable stone in your hand, imagine what might lie beneath. Because in the right light and cut, that rock may reveal a galaxy you never knew existed. In first place, Kimberlite, the diamond's dirty secret. Few materials hold more myth, power, and mystery in the world of gemstones than Kimberlite. This rock resembles construction rubble but hides the rarest mineral treasure known to man, natural diamonds. Chalky, greenish-gray, sometimes streaked with black or yellow, Kimberlite is unremarkable to most eyes. And that's precisely what makes it so dangerous to ignore. Kimberlite is an ultramafic volcanic rock formed during deep source eruptions that originate over 100 miles beneath the Earth's surface, in the mantle, where temperatures exceed 2,000 degrees Fahrenheit. These eruptions are rapid, violent, and vertical, blasting through the solid crust and carrying mantle pieces. Encased within those fragments, diamonds created under immense pressure over billions of years, then hurled to the surface in under an hour. But here's the catch. Not all kimberlite contains diamonds. Fewer than 1 in 200 kimberlite pipes yield stones of gem quality. The rest are barren. That makes kimberlite both a geologist's dream and a prospector's gamble. Across Canada, Russia, Botswana, and even isolated parts of the American Midwest, this rock has rewritten economies and triggered diamond rushes based on a single discovery. When diamond-bearing kimberlite is found, the diamonds do not first tell the story. It's the chemistry. Traces of ilmenite, chromite, and garnet serve as indicator minerals, whispering to experts that something extraordinary might lie beneath their feet. Ugly, heavy, often passed over. Kimberlite is the ultimate disguise, a volcanic vessel for Earth's most challenging and coveted gemstone. It is not just a rock, it is the gatekeeper to deep time and unimaginable pressure. And inside, a diamond that waited over 3 billion years to be found. Beneath the dust, the cracks, and the camouflage, each of these rocks tells a deeper story of heat and pressure, time and transformation. What appears worthless on the surface may in truth be a vault of ancient beauty. And as we've seen, nature doesn't always announce her treasures with brilliance. Sometimes she hides them in plain sight, wrapped in stone, waiting for the curious to look closer. If this video changed how you see the world beneath your feet, Consider subscribing to more stories from the hidden corners of Earth's geology. Leave a comment and tell us which rock surprised you the most. And the next time you pick up something that looks ordinary, remember it might just be extraordinary.